Hello everyone. So today my topic is bandwidth. Bandwidth is so what is a bandwidth? Bandwidth is that portion of the electromagnetic spectrum occupied by a signal. It is also the frequency range over which a receiver or the other electromagnetic circuit operated. More specifically, bandwidth is the difference between the upper average lower frequency limit of a signal or the equipment operation range. So now we continue with the definition of bandwidth. Bandwidth refer to the range of frequency over which a system signal or communication channel can operate effectively. It is typically measured in hertz and represent the difference between the highest and the lowest frequency that a system can handle or that a signal occupies. So here is the formula. Bandwidth equal to upper frequency limit minus low frequency limit. BW equal to F2 minus S1. So here as example, here is a bandwidth and here is F1. S1 is 300 Hz and F2 is 3000 Hz. So 3000 S2 minus 300 equal to 2700 Hz. So bandwidth is a crucial concept in various fields according to telecommunication, networking, electronic, and signal processing. It plays a vital role determining the efficiency and performance of communication system. Bandwidth is the frequency range over which equipment operated or that portion of spectrum occupied by the signal. So this is the wave frequency bandwidth. Frequency above and below are the carrying frequency by amount equal to the modulating frequency. Information carrying capacity measured in cycle per second, Hertz. Indication the difference between lowest and higher frequency. The higher the bandwidth, the greater volume of data that can be transmitted per unit time. So here is a example in AM broadcasting. In AM broadcasting, audio signal up to 5 kHz can be transmitted. If the carrier frequency is 1000 kHz or 1 MHz and the modulating frequency is 5 kHz, sideband will be produced at 1000 minus 5 equal to 995 kHz and at 1000 plus 5 equal to 1005 kHz. In the other word, the modulation process generate the other signal that take up a spectrum space. It is not just the carry at 1000 kHz that is transmitted. Thus, the term bandwidth refers to the range of frequency that contain the information. The term channel bandwidth refers to the range of frequency required to transmit the desired information. The bandwidth of AM signal described above is the difference between the highest and lowest transmitting frequency. Bandwidth equal to 1005 kHz minus 995 kilohertz equal to 10 kilohertz. In this case, the channel bandwidth is 10 kilohertz, and AM broadcasting signal therefore take up a 10 kilohertz piece of spectrum. Signal transmitting on the same frequency or overlapping frequency do, of course, interfere with one the other. Thus, a limit number of signals can be transmitted in frequency spectrum. As the communication activity has grown over the year, there has been continuous demand for more frequency channels over which communication can be transmitted. This has caused a push out development of equipment that operate at a higher frequency. So next is type of bandwidth. So we have three. One is a signal bandwidth. Signal bandwidth refers to the range of frequency that a particular signal occupies. For example, a music signal transmitted over the radio may have bandwidth spectrum 20 Hz to 20 Hz to 20 kilohertz. Point number two, channel bandwidth. The range of frequency available for transmitting a signal through a communication channel. It determines how much information can be sent over the channel in a given time. For example, in FM radio, each station is allocated a channel bandwidth of 200 kHz. And point number three is network bandwidth. It refers to the amount of data that can be transmitted over the network in a given amount of time. It is often measured in bits per second. For example, a typical home internet connection might have bandwidth of 100 megabits per second. So next is the importance of bandwidth. It has 3 points. One is data rate. The greater the bandwidth, the higher the data rate that can be achieved. This is because of more bandwidth allow more signal or higher frequency. We can carry more information. Point number two, signal quality. Adequate bandwidth ensure that the signal can be transmitted without a significant distortion or loss. A limit bandwidth may result in attenuation of higher frequency, leading to the signal regression. And point number three is channel capacity. The Simon-Hall-Tolley theorem shows that the capacity of communication channel increases with bandwidth. Channel capacity is letter C. It's given by C equal to B log 2 1 plus S divided by N. That where the C is a channel capacity in bit per second, and B is a bandwidth in hertz. F is a signal power, and N is noise power. So we continue with the application of bandwidth. So here we have 4 points. One is telecommunication. Bandwidth determines the capacity of telephone line, mobile network, and internet connection. Higher bandwidth allows for faster data transmission, which is essential for modern applications like video stream and online gaming. Point number two, radio and television broadcasting. Radio station and TV channel operate within a specific bandwidth. For example, each FM radio station typically occupy a bandwidth of 200 kHz, while a digital TV channel might use a bandwidth of up to 6 MHz. Point number three, networking. In networking, bandwidth refer to the data rate supported by network connection in interface. High bandwidth connection are crucial for cloud computing, data center, and high-speed internet access. Point number four is signal processing. In signal processing, bandwidth refer to the range of frequency that a filter or amplifier can pass or handle. For example, an audio amplifier may be designed to pass frequency between 20 Hz and 20 kHz, matching the typical human hearing range. So its next is bandwidth in different domain. So here we have 2 points. One is analog bandwidth. In analog system, bandwidth refer to the range of frequency an analog signal occupies. For example, the human voice typically occupies a bandwidth of about 3 kHz to 4 kHz, which is why telephone systems are designed to handle this range. And point number two is digital bandwidth. In digital system, bandwidth refers to the rate at which data can be transmitted. For example, Ethernet cable are rated for different bandwidth such as 100 megabits per second or 1 gigabit per second. So next is factor affecting bandwidth. So here we have 4 points or so. One is physical medium. The physical characteristic of transmission medium, copper, wire, fiber optic cable, wireless spectrum, affect the available bandwidth. For example, fiber optic offer significantly high bandwidth than the traditional copper cable. Point number two, modulation technique. Different modulation techniques require different bandwidth. For instance, frequency modulation requires more bandwidth than amplitude modulation to transmit the same signal. Point number three, signal to noise ratio. The quality of the transmission express a ratio of signal power to the noise power to the noise power impact the effective bandwidth. High SNR allow for more efficient use the available bandwidth. So point number four, channel environment. Interference, multipath fading, and the other environmental factor can reduce the effective bandwidth of wireless channel. So next is bandwidth efficiency. So we have 3 points here. First one is a definition. Bandwidth efficiency refers to the amount of data that can be transmitted over a given bandwidth. It is usually measured in bits per second. Point number two, maximization. Bandwidth efficiency can be maximized through advanced modulation scheme, error correction, and data compression technique. Here we have example: the quadrature amplitude modulation (QAM) and orthogonal frequency division multiplexing. The technique used in modern communication system like 4G LTE to maximize bandwidth efficiency. So we go to the challenge with the bandwidth. So here we have 3 points. One is interference. A small device use the same bandwidth, like in Wi-Fi network. Interference can be a call, reducing the quality and speed of transmission. Point number 2 is regulation. Government and international organization regulation allocation of bandwidth to prevent interference bandwidth different service, mobile network, broadcasting, satellite communication. Limit. Point number 3 is limit resource. Bandwidth is a finite resource, especially in wireless communication, where spectrum is limited. Efficient use management are crucial to avoid congestion and ensure quality of service. So the next is a real world example. So here we have the 3 points also. Internet bandwidth. ISP internet service provider offer different bandwidth packages such as 100 megabit, 500 megabit, or 1G or 10G, reflecting maximum data rate that user can achieve. Satellite communication system use a specific bandwidth like a Ka band, Ku band to transmit data over long distance. The system requires careful management to avoid interference with the other satellite and service. And the last one is wireless network. Wireless network operate in a specific band, 2.5G or 5 GHz, with defined channel bandwidth 20, 40, 80 MHz. The bandwidth of Wi-Fi channel affects maximum data rate users can achieve. So now we come to summarize. Bandwidth is a fundamental concept in communication networking and signal processing, determining how much information can be transmitted. The quality of transmission and efficiency of system under the bandwidth and implication is essential for designing, managing, and optimizing communication system across various applications, from simple audio transmission to complex data network and high-speed internet connection. So that's all for today. Thank you.